Good
And
morning.
here's Johnny.
Yeah, you should do that. Good morning, good afternoon, good evening. It's a wonderful Jefferson holiday. Of course, Tony doesn't know that. He's Canadian. He doesn't know. He doesn't know much actually. But
I
we
don't know.
found him. We found him, and so because the show supposedly is WTF? Where's Tony Fortunato? And so once we found him, we have to change it to Watch Tony Fortunato, right, Tony?
I think that's a good one.
That's a good one. Okay, well we'll keep finding use for the W. So with that, there are people out there watching you, Tony, and so we don't want to spend too much time away from the main topic. So why don't you take over? And I guess I don't need to introduce Tim today, do I?
Go for it.
Go for it. Okay, you got it.
Oh,
Go ahead,
all right.
Tony. Okay.
I thought you were using 10.
Yeah.
And here's Tony.
There you go. All right, folks. Let's just jump right into it. That way I don't chew up too much of your time. I'm just turning my screen sharing on. And there we go. And now you should see my screen with a whole bunch of packets.
Rackets.
And there we go. That's interesting. Oh, okay, good. I see it now. I was going to say I didn't see it in my preview, but now I see it. All right, folks. So what we're going to do is a little baseline exercise. I had to do this with a customer. Video is becoming a big thing if you haven't caught on yet. Video conferencing, video multicast, video surveillance, video. Everybody's doing something to do with video. I find, no offense to anybody listening, but the truth hurts sometimes. Network people are not very good video people or voice people, and vice versa. You've got a lot of voice people that are not very good at networking because that's not their forte. So what I find is a lot of people have misunderstandings with common terms, frames per second, codec, bit rates, all that kind of crazy stuff tends to trip people up. So what I usually suggest to people is when you want a baseline, I'm going to take you through exactly how I baseline stuff today. When you baseline an application, try not to get everything because that's impossible. Just get what you know. And then if you have the trace file, if you have some screen captures, you can always go back and learn more about what you don't know. And that's basically what I do all the time. So in this particular example, we have some requirements. The client is looking to deploy a video surveillance system for a security camera application. And the requirements they had, there's quite a few requirements. This is a summary of some of them. They'd like to use the existing wired and wireless network if possible. They don't want to have to build a whole new network, and that makes total sense. Security is always concerned, so obviously only authorized personnel should be able to access it. They would like remote and local access, of course. So if they're at home and they want a VPN in or whatever to see what's going on with the video surveillance, that's a big requirement. They are currently testing a solution, but it seems to be causing them network issues. And now this is where the finger pointing comes in, and this is where I usually get dragged in. So the vendor is saying it's a network issue, the network people are saying it's the product, and so on and so on. And basically, they're just spinning their wheels at this point. So I asked them a simple question. I said, you got a baselining document? Have you recorded bandwidth, protocols used? Have you got anything? And they said, no, we unpacked it, we gave it an IP address, it showed up on a screen, and it worked. I said, right, but the problem is now it doesn't work well. So this is where the baselining comes in. So since this is a baselining example, I'm going to skip the network design requirements because that's really got not much to do with it, but I will touch on it a little bit later on. So a little bit about video streaming, just so we're all kind of on the same page. I always say point one is the most important one. Video streaming products vary in many different ways. There isn't a similar default configuration for bandwidth or anything else when it comes to any kind of product. So just because you see the video doesn't mean the vendors all have it set up the same way. A really good example is if you do have a camera that says high definition, 1024 by 720, it might not give that resolution by default, whereas another vendor might do that. So here's some example items to consider. So things like resolution. Based on the video resolution, obviously that's going to generate a different load on your network. So if you have a standard definition video versus high definition 720 versus whatever, it's obviously going to give you a different load. Frame rate. A lot of people, again, network people may not even know that a typical video rate is 30 frames per second. That's your kind of so-so, I can live with frames per second rate. That may actually be too high for your network, for your application, for your PC. And 30 frames per second is not packets per second, folks. A frame is many packets. So try to remember that, because I've heard many people say 30 frames per second, and they say, well, that's 30 packets per second, and that's your first mistake. That has nothing to do with it. The codec, so based on the codec, the way this stuff is being coded and decoded, that's going to affect load. People on the voice side of it have run into this with phones, for example. They say, we have a remote office, and the voice isn't that great. The vendor says, try codec ABC, and oh, wow, now it sounds clear, and guess what? The requirements for bandwidth has gone down, and it's more tolerant for latency and jitter. Video payload size is a very popular term, and this is the number of bits or bytes, depending on the vendor, that are filled into a packet. And that's really important, because when you see a video or audio trace, you'll notice that the packets are kind of set, and that doesn't really change much. And that's really important, because every single product in codec and resolution and frame rate is going to give you a different, I'm going to say, end result. And the last is the PPS, the packets per second. And this is something that I tell people that you usually have to figure this out. If a vendor gives you this number, no offense, don't believe it. This is what you validate. You say, hey, look, the vendor say this is 30 packets per second. Great. Let's capture some packets and prove it. And I can't tell you how many times that it's not the same, and then the vendors will say, well, this is in our lab, and we tested it with such and such and such, and all the various components that you don't have, which means you're going to get a different default, which means the PPS is going to be different, right? So here's the network layout that we were playing with. We've got all these cameras. Some of them are wired. You can see these black lines wired, and some of them are wireless. And they basically did what most people do. They plugged in the cameras. Some were assigned with DHCP. Some were assigned with a static IP. They could ping them. They could see the video, and everything is great. Down here in the bottom right corner, they have a PC or a server of some kind running this DVR, and it's recording and monitoring all these cameras. Very, very, very simple, and I'm going to say practical layout. The problem is now they have network issues, right? So in the test methodology, traffic was captured to and from the test camera using various configuration parameters. So I'm going to back up 1 second to show you. I picked this test camera over here only for one reason. It was the most convenient. And since they're all set up default, it really doesn't matter which one I pick. Okay? So this test camera in the top left corner had a copper connection going to the switch. Of course, as always, I'm the consultant. I don't have access to the switch, nor do I want it, trust me. And the people there could not span or mirror a port during business hours. It's just the way they do things, which is fine. So I asked them, I said, could we just disconnect the camera for a moment? And they said, sure, and this is where I plugged in my tap. So in this case, it's a Garland tap, but it's whatever tap you have nearby. In a pinch, I even use hubs. I still use hubs for this kind of thing. Just make sure the half duplex is working properly and there's no mismatches, because I want to get the quality of the data. The load is not really going to exceed 100 meg. Well, I hope it doesn't. But that's the point, is that might do in a pinch. Okay? On to the next point. Like many products, the video could be streamed via various methods or protocols. And you'll notice this even with your home webcams. And you'll see in this example I used a webcam that I use in the office as well. They all have various options, and they're always worth looking into. The following camera configuration was tested. So I use an MPEG stream, I use a JPEG stream, and a JPEG image. This is the three most popular ways of getting video to some kind of recording device. The MPEG stream is obviously streaming non-stop, and it's using MPEG. This is where the codec comes in, because it could be MPEG-2, MPEG-4, that kind of thing. JPEG, everybody knows what a JPEG is. You take a picture with your smartphone, it's a JPEG. But if you get a whole bunch of these JPEGs together, guess what? It looks like a video. And you can tell it how many of these JPEGs you want per second. You want 10, 20, 50, whatever, and that gives you the impression it looks like a video. And the last is a JPEG image. So once a minute, once a second, it takes a little picture, and that's good enough, right? So those are the three most popular options. The camera default resolution was 640 by 480. So even though it said high def, it wasn't currently set for that. And that's important because that became a big sticking point. People kept saying high def chews up bandwidth, high def chews up bandwidth. When I asked if they were running high def, the answer started with it should, which means they don't know, which means we should go look into it. And then when I showed them it was all 640 by 480, they said, oh. And I said, so just drop the high def argument because that has nothing to do with it. So the test camera was connected via that Ethernet connection into that tap that I showed you, and the camera's video settings were left as default. And I always like to do this. I did a quick screenshot. Why? Because I just told you a moment ago the codec matters, and in this case it says MPEG-4 settings. I didn't think about that, but look, now I can go back and look at it and say, yeah, right. And you can see 640 by 480, and look, constant bit rate, CBR, 512K. I love seeing that stuff because guess what? I can prove it or disprove it with a simple trace. Because I can't tell you how many of these are talking about data that it puts into the stream, not so much the load on the network. So these are little tiny things that trip me up all the time. And you can see down here MJPEG settings and same thing. Okay? So screen captures, big fan of screen capture. You don't have to write stuff down. Just use snippet or whatever you want. Take a quick shot and put it into your documentation. So with the default configuration, I wanted to document the traffic generated using the application and the camera defaults. So I simply went to the app and I entered the IP address of the camera. That's it. That's all I did. I didn't tweak, I didn't tune, I didn't do anything. Why? Because that's what they did. So I was trying to replicate what they currently had. So I told them some things were worth noting. Number one, to get the video stream, they used HTTP, and that's your typical web browsing protocol. And that's important because, again, you could use other transport protocols. It doesn't matter that you could. The point is that's what it's using. Because it's HTTP, TCP gets involved. Well, guess what? You have to set up a new TCP connection for whatever that frame rate is. So if you had a frame rate of 10 frames per second, it actually sends 10 connections per second. That's a pretty chatty app, all right? And that's really important to understand. Now, if we get away from HTTP, yes, then everything changes. But the point is, this is the default. So obviously, the application frames per second is not the same as the network frames per second. So when I put it into this application here, you can see the default said 1 frame per second. That was the default. And here it says 450 KB. Now, people in the networking field who know me know this is a bit of a pet peeve. There's, I'm going to say, a de facto or a well-known rule that when you have a capital B, it stands for bytes. And when you have a lowercase b, it's bits. So when I see KB, I'm wondering, okay, is this kilobytes or kilobits? Because that's a big difference, right? It's a factor of 8. So what I do is I say, okay, 450 kilobits or bytes, I don't know. Let's see what Wireshark shows us. And if you take a look here, that's 500K, 500 kilobits. So that's about 450 kilobits. So this B, again, I'm not trying to be too nitpicky, should really be a lowercase b. This is bits per second. So this application is actually, in this situation, is accurate. It's telling me that this is my network throughput. So 0.5 meg for 1 camera. So if you had 10 cameras, that's 5 meg. And so on and so on and so on. So now what I did was I played with this setting from 1 to 10 because the guys were complaining that it was too jittery and they thought that was a network issue. It's not. It's because you're getting the video 1 frame per second, whereas your typical video is 30, right? That's why it looked jittery. There was nothing wrong. There was nothing wrong with the network. It's just the default of the app. So we bumped it up to 10, as you can see here. Look at that. The data rate actually went down. 100 kilobits per second. That makes no sense whatsoever. That should have gone up, right? And when you look at this pattern, it doesn't look anything like this, does it? So we're looking at these two things, and I'm saying, what? That doesn't make any sense. What happened here? It's impossible that you have a greater frame rate that results in less traffic. So what I did was, I took a look at this trace when we upped the frame rate, and you can see the web server in the web camera getting overloaded. And how do I know? Look, to be sarcastic, it says right here, overloaded. So the web service is temporarily overloaded in my webcam. So when you increase the frame rate on that DVR, it hits the webcam to the point where it can't handle it and starts sending out these messages. So what I'm going to do right now is I'm going to kind of flip to the trace file, or the trace files, for example, just so I can show you something. Hey, Danny, do you guys see the trace file yet? Because I don't see it in my preview window. You see trace files on your screen?
Yeah, I see it.
Okay, good. Good, because like I said, my preview is black for some reason. I don't see it. Oh, there it is. It just updated.
I didn't want to be the first one to say anything because I don't know what a trace file looked like.
Trust me, Danny. Neither do I. So
but,
you can.
But then when Tim said he saw it, then I saw it too.
So when I go through a baselining exercise, I'll show the audience something really simple. This is our 1 frame per second. This is the one that worked. And I explain to people protocol analysis can be very simple if you let it. And it's a simple exercise of looking for a pattern. That's it. So in this example, do I see any patterns? Yeah, look, 2 data packets and an ACK. 2 and an ACK. 2 and an ACK. That's definitely a pattern. What else do I see? I see this 1314 for my maximum size. Sure, that's a pattern. So as you go through your trace file, you can say all these patterns equal good. Therefore, this pattern must equal bad. This is the 10 frame per second. So the first thing we look for whenever you have a performance issue is right here, this column I have is my delta time. And if you take a look at the good trace, I'm just scrolling through here very gradually. See here it says 0.00. This is the second, so 0 seconds. So if I take a look here, I'm trying to find out if anything gets close to 1 second as I just look through here. And they're all 0, 0, 0, 0, 0. See? Everything is good. And you can kind of go through real quick. People see me doing this. They think I'm looking at the matrix screen. No, it's because I'm looking at something very focused. Very, very easy. So this doesn't really go over 1 second. Now, when you get into Wireshark, there's much easier ways to do that. But for now, this is good enough. If I come over here to the quote-unquote bad one, and I start going through this trace, you'll see the zeros again, just like I showed you a second ago. And as we go through the trace, if that ever changes, something looks odd. But if you also pay attention over here, you'll notice, see that? This is the pattern we had before here on the right-hand side. Look, the pattern changed again. See that? Mm-hmm. Right? And then data, and then the pattern changed, and data. So as I go through this, again, I'm not going to take too much time going through this, but as you go through this, sooner or later, you're going to get to a point where you're going to say, well, what the heck is that? And then that's when things start to go bad. And usually the big indicator is this delta time along the side. So, oh, there you go. There's one right there. 5-second delay. See that? 5.3 seconds. And you say, wow, what happened? Well, that's not helping me. I have to look prior to find out what happened. Look, service temporarily overloaded. See that? So every time the web camera says I'm overloaded, the application waits 5 seconds before it tries again. It doesn't want to hammer it further. It's going to give it some time to breathe, right? So this is the most basic form of protocol analysis, is at a superficial level, you see a pattern, they're different, they're the same. When they're different, what's going on? Even over here, if you take a really good look, you can see I have these nice big packets, 2, 1, right? 2 to 1, all that, all the way down. And over here, look, they're all tiny. And when you say, wow, why are they so tiny? Take a look at the right-hand side. Reset, 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 reset. And people always ask me, I don't know what a reset is. I said, you know what a reset is? A reset is when you're speaking to somebody and they're done talking with you. They have 2 options. They can say, see you later, nice chatting with you, which is called a fin, or I can punch you in the face, and that's a reset. So a reset is a very abrupt way of ending a conversation because I don't have time to be polite right now. And that's the way I explain a reset. So there's lots of reasons why you get them. The point is they're there, and they weren't there when it worked. So this is the most common way of starting to learn what the packets mean. So what I'm going to do is I'm just going to quickly go back to the slide. There you go. And okay, good. So now you'll see we're back to this again, where it was overloaded. And then the last way we could actually do this, which came up later on, was to embed this video stream into a web page. So they got like a web page with a little video in the corner of the live stream, and we actually measured that as well, and that's this MJPEG, and it's 3.5 megabits per second. See? So at the end of all of this, I told the customer they should consider a variety of streaming configurations depending on the situation and where the camera is being accessed from. For example, I would strongly, and I told them this, I said if you have a camera in an area that's not that sensitive, like a parking lot, you just want to keep your eye on the cars or a delivery truck, you might want to consider 1 frame per second and that simple JPEG thing, which was pretty lightweight. If you had an area that's very sensitive, like inside the hallway near the main office that you want a real stream, then you'd want to make sure you had a cabled connection and used a higher throughput option. So depending on the combination of what they're trying to do, I suggested various configuration parameters. And that's pretty well what I said down here. As far as access and security goes, I told them that they should just consider a simple VLAN and put something called an access list that would filter out addresses that aren't allowed to be there. So if the IP department has an IP subnet, you allow that through. And guess what? Now they can see the camera or the DVR. I found out later the cameras also support something called RTP, which use a lot with your mobile phone. And when I heard that, I said, you got to test that, because if the quality is good or good enough, this would probably be very lightweight, because this has to run over a cellular network, right? Which means it'll probably run even better on your Wi-Fi and your LAN. So I'm going to take a few seconds and go back to my my trace file. I guess I'll just take 2 seconds. Tim and Denny, what do you think? Was that okay?
Yeah.
Or did I go too fast?
No.
You're fine.
Is that all right?
Yeah.
Okay. All right. So what I'm going to do is just take a moment, because I want to briefly go through the trace file. And again, people seem to enjoy having somebody point things out, whatever it happens to be in a trace file. So I'm going to use Wireshark here, and for the people who don't use it that much, I'll show you what I'm doing as I do it. There's these magnifying glasses at the top, and I always say if you're over the age of 40, you probably like to use the magnifying glass, and that's going to show you, obviously, a zoomed-in view. So this is not a permanent setting on your Wireshark. It's more of a temporary setting. And what are we looking for? Well, the beginning of a conversation is this SYN, right? That's what TCP does, and I've talked about that before. That allows me to take a look at how that device is set up. So in this case, this guy's talking to the actual camera. And so I know his TCP window size, which tells me how much data he can receive, just generically speaking. The maximum segment size is how much data you can put inside TCP, the payload, for example. And the last thing is the SAC permitted, which just simply put, it's a more efficient retransmission algorithm. So that's good enough. Now what about the camera? The camera's an appliance. Well, look, I can find out exactly how it's set up here. The camera has a window size as well. It also has this maximum segment size, and it also has this SAC permitted, and that's good to know. So this is kind of important to understand. When people troubleshoot appliances, they always say, I don't know how it's set up. I don't have access to it. And I say, perfect, just capture some packets. It'll tell you. This is exactly how the driver's set up on that camera. The other thing is, when you talk about HTTP, which is our web browsing protocol, which I've touched on in the past, you can see this is that DVR software saying, I'm going to go get that image. And he says, I'm going to use HTTP 1.0. Well, to date, there are 3 popular versions of HTTP. 1.1 is more efficient than 1.0. So again, I would ask them, hey, is there some way we can check that out and see if there's a setting in the app that lets you use 1.1, right? These are all little tiny things that I always suggest people look for. The other thing is, just a little bit about TCP now, because we're touching on a lot of different topics. I said go get something. Well, I love when this happens. So the DVR said to the camera, give me an image. The camera comes back 2 milliseconds later, because I have my delta set up here, and 2 milliseconds later he says, yeah, I got the GET request, just hold on. Why didn't he send me data? Because he couldn't. And this is a telltale sign with servers when they're a bit overloaded. They'll send back an acknowledgement real quick so you don't resend the GET command. He got the GET command. He just can't send the data right now. And that's the little kid with his hand in the cookie jar. These are great little packets to find. So I said GET. He says, yeah, thanks, I got that. And then look, 265 milliseconds later, he starts sending the image. So that's very important to understand, that the camera gave us a huge clue. Hey, this isn't cool. And then all of a sudden, he sends the video or the image or whatever he's sending 265 milliseconds later. We know that's not the network, so that's got to be the camera. So that when I see something like that, I always ask the simple question, does that happen again, or was this just an anomaly? And then so on, and so on, and so on. Okay? And as you can see here, I said get. He sends me the ACK, 2 packets, and then I send back a data acknowledgement. I said, hey, look, ACK, I got your packets. And I know I got the packets, and what I do is I tell him my new window size. This is a great number to look at, folks. This is your barometric pressure of health, right here. And that tells me how much data I can handle. So look, 66780, same, 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 same. So you know what that's telling me? The receiver, the DVR, is handling it no problem. See that? If he was having a problem, he'd start running out of gas. He'd go 66, 50, 40, 30, 20, that sort of thing. So there's a tremendous amount of information in this screen, believe it or not. So as we go through this, I'll show you another little one. As I go through these and I look at 66780, see how your eye tends to just gravitate to that number now? Mm-hmm. And you can just quickly go through that just by scrolling down. And this is, like I said earlier, people think I'm looking at the matrix screen, and it's not. I'm just looking at a very simple value that sticks out like a sore thumb. So I can even say at the end of this conversation, I can say, wow, this guy was fine. So the DVR, because that came into question, the server that the DVR app was on, is that causing performance issues? Again, no, it's not. We've just proven that. Okay? And then you can see there's another one. HTTP OK, that was the end of this. And now fin. Remember that? The polite way of saying goodbye. Remember the ugly one I showed you a moment ago? They weren't fins, they were resets. So we've proven, I tell people, just pretend you're doing the, the court of law thing that you see on TV. Ladies and gentlemen of the jury, look, we've got proof here that the receiver was fine, and we have proof that he can actually end the conversation politely and not punch people in the face. We have the proof right here, folks. And then move on to the next trace, okay? So you can see there's my fin, my ACK, and then again, there's the SYN to start up a new conversation, SYN ACK, and then go get. So on, so on, so on, and so on, okay? So that's it. Here, let me stop sharing the screen.
Go to the Q&A panel, Tony. Go to the Q&A panel.
Oh, yeah, I don't have it on today.
Huh? Yeah, there
we go.
Yeah, there are 2 questions, and one is from Casey, and one is from Bedamir. See if they're relevant, and they are. Maybe we can address them.
Yeah, good. Did you use the built-in web server to get a stream, or some software on a DVR? Yeah, the web server was built into the camera, and then the DVR pulled that data from the camera. So there's 2 parts to it. The DVR software, which has its own web server, but it was querying the web server in the camera itself. Okay? Hope that answers that one. If not, Vladimir, let me know and I'll try to reword that. Could it be Google's throughput in the lag? Google throughput. Yeah, that's a good joke. I think he's referencing me and my Google issues with my video getting cut off. But
I think it's a personal issue, actually. Yeah.
I know, eh? Yeah, again, this is on a local network, right? So I just don't want people to get confused. This is on a local network, and the DVR and the camera's on the same network, be it copper or Wi-Fi, but they are on the same network.
Yeah.
And there you go.
Casey might be. I'm not sure, but Casey might be asking about the lag on a live show, but I'm not sure.
I'm not sure either. Yeah. Who knows?
Yeah.
I don't know. Sometimes he's got a good sense of humor, so I'm taking it as sarcasm. This is kind of important though, because a lot of network people shy away from baselining video and voice because it's not familiar to them, and because there's not a lot of cues as to what's going on. And I'm trying to show you that there are many cues that you can look for, regardless of voice or video. Right? I was looking at TCP, for example, for a lot of the cues that I was looking for. And that can be used for anything, FTP, HTTP, any protocol, not just video or audio. Maybe the next one we'll do will be an audio one using UDP, just to get people familiar with that. But again, my advice to you folks, capture your packets, take your screenshots, file it away somewhere. I'm not asking you to write a 500-page report, and then when you need more information, you can go back and reference it. And that's it. It's my soapbox.
Yeah, but one thing I wanted to point out, and I think you did early on, was that you need a tap to look at real-time flows, because the switches and span ports, they groom it. So if I can't tell you how many times someone's called me and said, I looked at my voice over IP through my span port and it looks wonderful. And it groomed it. Looked great. It sounds terrible.
Yeah, the tap's very important. I can't tell you how many times I pull it out of my bag and network people say, what is that, a hub? And I say, well, no, kind of. And then you explain what a tap is, and they go, oh, wow, is that new? And it's, no, you just didn't know about it.
Well, and plus you got people out there that sell, quote, a tap, but it's got a bus in it, and it's got the span port chipset, and that's not a tap.
Yeah, right.
That's just dedicated span port. And, and no matter what you do, whether it's a VACL, which is a VLAN access control list, or a span port, it will muck up your visibility, and you'll. But of course, if you want to show someone how beautiful your network is, you show it through a span port. All the RTPs and RTSPs will be 0, 100% throughput. It's all clean, perfect.
Yeah, and actually, I just ran into a customer 2 weeks ago who did a span on one of his switches. Vendor remained nameless. And any packet size over a certain size was just dropped from the actual span port.
Yep.
So you really got to watch out, folks.
And one other thing I thought was really great is people don't realize most cameras, when you buy them, they refer to two things. They refer to the pixel diameters, you know,
right.
And then they also refer to the TVL, which are television lines. And so if someone says you got a TVL of 600, and it's a high definition camera, it ain't.
Right.
Okay. So you've got to understand the difference between TVL and pixels.
Yeah, that's a whole language in itself.
Affirmative.
Well, Tim and I both have technical background, but we spend our adult life in marketing, and let me just tell you that there is no quality in control in marketing. I can't
Thanks
help
for
it.
that one.
Yeah, it's just the way it is. So just be careful. But anyway, I think we should close the show. We did a very good job keeping it around 30 minutes. But before we close, I just want to mention that we got 2 great shows coming up this week. We have Paul Orford coming back on Wednesday and giving us a guided tour of his trilab.com or trilab0.com, his trilab website. So that would be very exciting. And then of course we finally have Mike Panaki coming on the show on Thursday, and this would be 1 p.m. my time, 1 p.m. Pacific Standard Time. And so I haven't made the announcement yet, but I will soon. So, and again, that would be a live show. So now is the time to ask questions.
We did that under severe threat of loss of life, limb, and reputation if he didn't get on before interrupt.
We've been absolutely. So Tony, with that, I want to thank you for taking time out from your day job again. And I think people really like this show. I can just tell from the number of live audience out there, they really wanted to. This, I think you're right. I think this is sort of in the blind spot, right?
Yeah.
You know, it's most of us who are in IT, we just kind of think of video as that one thing that people do. They can't last, and it's a fad. Why bother spending time understanding it?
Just like the internet.
Just like the internet, you know, we're still trying to figure out what that is.
Just like IPv4, let's try to ignore it.
So with that, I'm going to close the show. I want to really thank Tony and thank them. And we got a lot more coming up this week. Okay? With that, bye-bye.